Good morning to everyone. I'm Dr. Sumi MS. The topic of my today's presentation is pure capacitive circuit from sinusoidal steady state analysis of electric circuit analysis. On completion, the students will be able to understand about a pure capacitive network and also derive a purely capacitive circuit along with its power curve and phasor diagram. Pure capacitive circuit. The circuit containing only a pure capacitor of capacitance C farads is known as a pure capacitor circuit. These capacitors stores electric power in the electric field and this effect is known as capacitance. The capacitor consists of two conductive plates which are separated by the dielectric medium. This dielectric material is made up of glass, paper, mica, oxide layers, etc. In a pure AC capacitor circuit, the current leads the voltage by an angle of 90 degrees. When the voltage is applied across the capacitor, then the electric field is developed across the plates of the capacitor and there will be no current flow between them. If the variable voltage source is applied across the capacitor plates, then the ongoing current flows through the source due to the charging and the discharging of the capacitor. Derivation of capacitor circuit. A capacitor consists of two insulating plates which are separated by a dielectric medium. It stores energy in electrical form. The capacitor works as a storage device and it gets charged when the supply is on and gets discharged when the supply is off. If it is connected to the direct supply, it gets charged equal to the value of the applied voltage. This is the circuit diagram of a pure capacitor circuit. Let the alternating voltage applied to the circuit be given by the equation V is equal to Vm sin omega t and the charge of the capacitor at any instant of time t is given as Q is equal to C into V, where V is the voltage applied and C is the capacitance value in farads. Current flowing through the circuit is given by the equation I is equal to dq by dt. Putting the value of the charge Q from the equation 2 in this previous equation, we get I is equal to d by dt of Cv, and substituting the value of C in the above equation, we are getting the current equation as I is equal to Cvm d by dt sin omega t, and it can be written as Vm by Xc sin omega t plus pi by 2, where Xc is equal to 1 by omega c is the opposition offered due to the flow of alternating current by the pure capacitor, and it is called as the capacitive reactance. The value of current will be maximum when the value sin omega t plus pi by 2 is equal to 1. Therefore, the value of the maximum current can be given as Im, which is equal to Vm by Xc. Substituting the value of Im in the equation 4, we get I is equal to Im sin omega t plus pi by 2. Phasor diagram and power curve. In the pure capacitor circuit, the current flowing through the capacitor is found to lead the voltage by an angle of 90 degree. The phasor diagram and the waveform of voltage, current and power are shown in the upcoming diagram. In the diagram, the red color shows current, blue color is for voltage curve, and the pink color indicates the power curve. So here this is the given diagram with voltage, power and current curve. And here, when the voltage is increased, the capacitor gets charged and reaches its maximum value and a positive half cycle is obtained. Further, when the voltage level decreases, the capacitor gets discharged and a negative half cycle is being formed. In the curve, we notice that when the voltage attains its maximum value, the value of current is 0. That means there is no flow of current at that time. When the voltage is found to be decreased and reaches a value of pi, then the value of voltage starts going to negative and the current will attain its peak value. As a result, the capacitor starts discharging. This cycle of charging and discharging of the capacitor continues, and the values of voltage and current are not maximized and minimized at the same time because of the phase difference, as they are out of phase with each other by an angle of 90 degrees. The phasor diagram is also noted at the left side, where the current Im is found to lead the voltage by an angle of 90 degrees. Power in pure capacitor circuit. Instantaneous power is obtained by P is equal to VI, and we can substitute the values of V and I, and we are getting the value of P as Vm by root 2 into Im by root 2 sine 2 omega t, and substituting the values we are getting the P value as 0. Hence, from the above equation, it is clear that the average power in the capacitive circuit is 0. Quiz questions on pure capacitive circuit. Define a pure capacitive network. Derive a purely capacitive circuit and obtain its power curve and phasor diagram. Thank you.